Dear students, good morning, good afternoon, good evening, everyone. In today's session, we'll see normalization in database. So, topics covered are what is normalization, functional dependency, 1NF, 2NF, and 3NF. So, first, let's see the definition of normalization. Normalization is the process of efficiently organizing data in a database, and normalization have two goals. Means when we organize the data into database, at that time we have to consider the two goals, and that first is eliminate redundant data, and second goal is to ensure data dependencies make sense. So let's try to understand these goals by using simple example. So first goal is eliminate redundant data. Redundant data means repeated data. So here we try to reduce the redundancy. Consider a table which is in unnormalized form, which contains the details of the student, student ID, name of the student, course ID, course number, and course detail. So values for all these attributes are given here. Now you can see the course, for example, student ID 100 is having course 01. Name of the course is a database, and course details, what that student is going to learn, that is given here. Now there is a probability that many students can select the same courses. So every time we need to repeat the course ID, course name, and course detail. Consider the another course, that is a course ID 02. For that course ID also course name, course details are given, and frequently they are given for multiple students. Means the same values we are repeating again and again here. So by using the normalization, we can eliminate this redundant data by decomposing the table. By decomposing the table means dividing table into two sub tables. So we can see this student details table can be divided into two tables. First table is a student, another table is a course. Student table contains all the data which are related with the student, means ID of the student, name of the student, and course ID of the student. Again, course table contains course ID, name of the course, and description of that course. So here it shows that normalization is done by decomposing the table, and redundancies are reduced here or eliminated. Another goal you can see by using this example, ensure data dependency makes sense. Now we have seen that to eliminate the data redundancy, we are dividing table into two subtables. Okay, but when we are separating these two table, at that time a relationship between that two tables must be established. Means now the student table is a separate and course table is a separate, but I want to establish connection between or a relationship between the student table and course table. For that purpose, I will create one more table having name as the enrollment table, and it contains two attributes, student ID and course ID. By using student ID, I can access all these details of student, and by using course ID, I can access all the details of course. So in this way, the second goal is achieved. Now next point is benefits of normalization. The first benefit is a lesser storage space. So in the normalization, we are eliminating the redundant data. Okay. Therefore, it takes the less storage space to store the data. Next is a quicker updates. Now you can see here, if I use the normalized data in this, I want to update the course name from database to database management system. Okay, if I make the change only once here, it will reflect it to the all the records given in the student table. If I am not using the normalization, then for every record I am supposed to write the database management system. But if I use the normalization, I have to do change at only one place and it will get reflected to the other places also. So here quicker updates will be made and less data inconsistency, and same data is duplicated, therefore inconsistency will not happen. Again, clearer data relationships. Here table shows the logical link between entities. Now you can see the student, by using this enrollment table, student ID and course ID relationship is established. And in the normalized data, we can add the new records without any confusion. So all these are the benefits of normalization. Now the next point is a functional dependency. Functional dependency means one attribute uniquely determines another. So here you can take a simple example that if I know the student ID, I can identify name of the student. Means student ID uniquely determines the name of the student. So by using this syntax, we can give this functional dependency as the relationship x gives y holds whenever two tuples have same value for x, then they must have same value for y. By using this syntax, we can show the functional dependency. Now you can consider this a student table in that student ID and names are given. Now you can see here each student ID uniquely identifies name of the student. So here functional dependency exists. Take another case to identify the functional dependency. Suppose we want to find out functional dependency between name of the student and department. So here name we are considering as a x value and department as a y value. So we can see here the value of x, that is the name of the student, is repeated here. If for these x values, y values are also matching, then we can say functional dependency exists here. So by using this syntax, P1 of x means the Mira name for student ID 100. P2 of x means Mira name for the student ID 400. They both are same, then we have to check their y values. So both the places math subject is there, means y values are also matching. Therefore, in this case, the functional dependency exists for this relation name gives department. Now consider next example. Here we can see the relation name gives department. For that, case 1 is that name, that is a Mira, is matching for student ID 100 and 400. Okay. Now we'll check Y values for this name. Y values are also match, both are matching. Okay. Means for X value Mira, the functional dependency exists. But case number 2, here Sarah name is also repeated. So we have to check functional dependency for this records also. Here names are matching but departments are not matching. So for this case number 2, the functional dependency does not exist. Therefore, conclusion will be there for the complete table or for the complete relation, the functional dependency name use table does not exist. If either one of the record is not following the functional dependency, then complete function does not follow the complete relation does not follow the functional dependency. Therefore, here functional dependency does not exist. By using combination of attributes also we can find out the functional dependency. Let's take example for it. First consider this table. In this table course IDs are given, course names are given and course details are given. Now given relationship is course ID and course name togetherly gives course details. Course ID and course name gives course details. So here you have to consider the course ID and course name as X value and course details as Y value. Here X values and Y values are matching. Therefore, the functional dependency exists here and other attributes are not duplicated at all. So no need to think about uh, other rows or tuples. Again consider this courses as a table and suppose course number 3 is artificial intelligence. Here course ID and course name is X value and course detail is a Y value. If you consider this course ID as a 1 and name of the course as a database, it follows the functional dependency because Y values are matching. But if you consider the course ID as a 3, name of the course as a artificial intelligence, but here descriptions are not matching. The course details are not matching. Therefore, the functional dependency does not exist in given relation. Now we'll see the steps in normalization. So a normal form is a state of relation that results from applying simple rules regarding functional dependencies to that relation. In the normalization, there are three steps: first normal form, second normal form, third normal form. In first normal form, multi-valued attributes will be removed. Multi-valued means repeated value. In second normal form, partial dependencies will get removed. In third normal form, transitive dependencies will get removed. So let's consider the first normal form. It is also called as a 1NF. So main feature of 1NF is it removes the multi-valued attributes. 1NF does not allow composite attributes, multi-valued attributes, and nested relations. So example of composite attributes is address. Address contains the details of street also and city also. So these composite attributes will not be allowed in 1NF. Also, multi-valued attribute means, for example, here the student table schema is given, or a student table record is given, which contain ID of a student as a 100, name of the student as a Mira, and it has a two courses, database and networking. So here this multi-valued attributes will not allowed in 1NF. Again, 1NF does not allow the nested relations. Nested relations means nesting of a table. For example, student is a table in which student ID, student name, department is given, as well as the attributes of course table are also shared. That is a course title and date of completion. So we'll see how this composite attributes, multi-valued attributes, and nested relations are removed in first normal form. Now take example for the composite attribute. Here the table contains the student ID, name of the student, and address. Now here address is a composite attribute because it contains the street number as well as city also. So while doing in one normal form, this address column will be splitted into two parts. First column will be street number and another column will be city. So in one NF form, the table will contain total four attributes. And first as the student ID, second as the name, and third attribute address will get divided into two, that is the street number and city. Now this table shows the normalized data or data in 1NF. Now let's see example to remove the multi-valued attribute. Now here you can see that for every student, for the course attribute, multiple values are given. For example, Mira have two courses, Sarah also have two courses, Iba have two courses. So like this multiple values we cannot give for the attribute. So to reduce this, to remove this multi-valued attribute, the table will be given as student ID, name of the student, and first value of that attribute, that is a database. Again, for this second value also, again write down the student ID, name of the student, and course of the student, the networking. Similarly, for next record also, it is done. That is a multi-valued attribute is removed, and each row contains the atomic value, which is shown in this figure. Now see normalization for nested relations. Here is a student table which contains the student ID, name of the student, and course information. This course information table contains the course ID and name of the course. So this table can be decomposed into following tables. First table containing the student details only, that is ID of the student and a name of the student. The second table contains the course ID and course name. And third table, enrollment, shows the mapping between student ID and course ID. And this satisfies the first normal form. So in this normal form, student details and course details are written separately. And finally, mapping is done between these two tables. Now next normalization form is the second normal form. So in 2NF, partial functional dependencies have been removed. Okay, means it contains only fully functional dependencies. For that, first you should know that a prime attribute means what. You can take an example. In this table, student ID and course title togetherly makes a primary key, and by using that, date completed for the course can be obtained. Okay, so here this course title is called as prime attribute, and name, department, date completed are non-prime attributes. Also, you can see the relation by using student ID. We can find out the name of the student as well as department of the student. Here, this relation that student ID can find name and department, it shows the partial dependency. Means by using only one key from the primary key, by using only one attribute from primary key, you can give values of the another attribute. Means here name and department depends only on student ID. They don't need a course ID. So this is partial dependency, and that's why this table is not in 2NF. So to remove this partial dependency, again table is divided into two or decomposed into two. The first table contains the student detail having student ID, name and department. And another table is a student course table which shows student ID, course title, and date completed. For first table, name and ID can be obtained by using a student ID. Means student ID is a primary key. Therefore, it shows the fully functional dependency here. Also, for another table, student course table, date of completion of course can be obtained is obtained by using student ID and course type. So here partial dependency does not exist. Therefore, this relation is in 2NF. In 3NF, it removes the transitive dependencies. It means that when a non-key attribute depends on another non-key attribute instead of primary key, then 3NF removes these dependencies by creating the separator table. Now consider this simple example. Here student ID is a primary key. Okay, so customer ID is the primary key which can identify name of the customer, salesperson, and region. Okay, also it shows the dependency in the sales table. Uh, in the same table, you can identify region by using salesperson. Means it's like this. It gives functional dependency x gives y and y gives z. Means customer ID gives salesperson gives region. But we don't want this transitive dependency. So table will be decomposed into two. First table will be customer table having customer ID, name and salespersons as attribute. And another table will be considered as the sales in which salesperson and region. These two attributes will be there. Consider one more example for 3NF. Here is a table which is in unnormalized form. Okay, and it shows that student ID gives the name of the student and department, and by using department we can find out the department head. Means transitive dependency exists here. To reduce this transitive dependency, two tables are created. First table is student and another is the department. So student table will keeps all the details of the student, and department table keeps details for all the department name and their department head. So here non-key attribute depends on primary key only. Means here name and department depends on student ID, and here department head depends on department name. So in this way transitive dependency is removed and the function is in 3 and F. So in this way we studied the normalization in database. Thank you.